Welcome to this video on multiplying a monomial to a polynomial. By the end of this video, you should be able to identify like terms, combine like terms, and use the distributive property to multiply a monomial to a polynomial. Alright, so I want to do a little review of when you are multiplying variables. If I take an x and I multiply it to another x, the base is going to stay the same. But these each have an exponent on one, so x times x is actually x squared. All right, let's try another one. I have x times x, so the base stays x. But I have two exponents there and one exponent there, so x squared times x is x cubed. And there's a little typo here. See where it says z? Just change that guy to an x. So I have x squared times x to the third. The x stays, but I end up with x to the fifth. Are you seeing what's happening as we do these? On this first one, 1 plus 1 is 2. Let's look at the second one. 2 plus 1 is 3. And then look at these exponents. 2 plus 3 is 5. So what you're really doing when you're multiplying a monomial to a polynomial, you'll use something called the product rule. Now I'm going to show it to you in math first, and then we'll get the English version. If we have x raised to the a, and we're going to multiply it to x raised to the b, its answer will still have the x at the bottom, but you're going to add those exponents together, so you would get a plus b. So we're going to add exponents when multiplying. Alright, now when I say add exponents when multiplying, we're to like bases. Okay, and we'll talk about that as we're walking through these. Okay, so let's try a couple of these. So we have an x in front of a parenthesis. Hopefully we're remembering that means we need to distribute. So if I take x times x, remember both of those x's have a 1 on them, so that becomes x squared. Then we have x times 4, which will be 4x, and that's as far as we can distribute. All we would need to do is make sure we're in standard form, biggest exponent, next biggest exponent. So this is actually our final answer. Okay, it doesn't matter what the letter is. We can use any letter that we want. So let's try it in number 2. It's a very similar problem. I need to take 9a times a. Technically, it's not written there. There's a 1 in front of that a. So 9 times 1, you still have a 9. A times a is a squared. Okay, now let's distribute it to the second one. 9a times negative 1 will become negative 9a. And then I just check for standard form, which this one is in. So that's my final answer. Okay. So let's take a look at 3. 3 is almost the same. I just started using some bigger exponents to kind of give us a better feel. Negative 6p, remember there's a 1 on this p. So when I multiply it to the p inside, I need to add those exponents. Negative 6p times p to the fourth will be negative 6p, and there's a total of 5 p's now. Okay, we distributed to the first one. Let's distribute to the next one. Negative 6p times negative 8. So we got negative, negative, which is positive, 48, and then p to the first, and there is no p there, so it just stays p to the first. It's in standard form. That's my final answer. Okay, so we've done a monomial to a binomial on all 3 of these problems, but we can take it out even further. This is a trinomial, and we're just going to keep the distribution going. So we have x times x squared. Remember there's a 1 on this x for a total of 3 x's. Now I'm going to take x times negative x. It's a positive times a negative, which is a negative. X times x is going to be x squared. Then I have x times 3 will be positive 3x. So I've taken this monomial and sent it all the way through the trinomial. I've gone all the way to the other parenthesis. I'm done. Check for standard form. 3, 2, 1. We're in order. And there we go for our distribution. Now, let's make it a little bit harder. I'm going to bring y into us now. So we're going to look. We want all of 3xy times x squared. So it will still stay a 3. For x's, I have 1 here and 2 there, so I'm going to say x cubed. And the y has nothing in that first term to multiply to, so it just stays y. So what we did is we took this and we multiplied it right there. Now let's go to the second term. Okay, 3 has nothing to multiply to, so it's going to stay 3. I have 1x here and 1x there for a total of 2 x's. I have 1 y here, 1 y there for a total of 2 y's. All right, let's go to the third term. So 3 times, there's a 1 in front of there, that's why it's staying a 3. The x, there is no other x to multiply to, so it remains x. And there's 1 y here and 2 y's there, so that gives me a total of 3 y's. So for standard form, I'm just going to look at the x's. X cubed, x squared, x to the first, we're in order. We are good to go. Okay, now we have p's and q's. It's not any harder, it just looks different when we add different letters in. Okay, so let's take this p squared and q cubed to this first term. That's really hard to say. So the p stays the same. There's 2 and 5, so there's 7 p's. The q is being multiplied to the q squared, so it stays q. I have 3 q's and 2 q's for a total of 5 q's. Now I'm going to go distribute it to the second term in the parenthesis. P, there's 2 p's and 1 p. It's got to be minus because this is positive times a negative. We have a total of 3 p's. There's 3 q's times 1 q means we have a total of 4 q's, and that's our final answer. Okay. Now this is coming back to some of what we did before. There's a minus here, which means we're technically got some subtraction going on. So let's just take a look at everything that's happening. I see some distribution here that has to happen. So we have 6x times 2 is 12x squared. We have 6x times negative 3, which will be negative 18x. Now we're done. That ended that distribution. Now we have to distribute the negative 5 through this parenthesis. Negative 5 times 2x squared is negative 10x squared. Negative 5 times 9x is negative 45x. And negative 5 times negative 3 is positive 15. Now that everything's distributed through, we need to look to see if there's any like terms. We had so much going on with this one. So I'm just going to kind of help myself look at it because there's so much to look at. I've got an x squared, and when I look, I have another x squared right here, but no others. 12x squared minus 10x squared. Now we're back to addition, subtraction, where exponents don't change. So we get negative 2x squared. You're only going to change your exponents when you're multiplying. I have negative 18x minus 45x. So negative 18 minus 45 more is going to be negative 63. And remember, your exponents don't change when you add or subtract, so it just stays x. And I have a constant out here on the end of 15. He has nobody to combine with, so I'm going to add the 15 on the end. And when I look for standard form, I have 2, 1, none. We are in standard form. All right. So we can also find area. This is the same idea. It's what we've been doing. It could have been applied to a figure and told the area. So remember, area equals length times width. So you're just multiplying the sides here. So really what we're saying is 2x times 5x plus 3. Okay, so I'm going to distribute the 2x to the 5x plus 3. 2x times 5x is 10x squared, and 2x times 3 is plus 6x. I don't see like terms. I check for standard form, and we are all good there. So the area of that rectangle is 10x squared plus 6x. All right, so hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.